Today we are going to learn about mastering custom exceptions in Python. You'll discover how to design and implement custom exceptions for clearer error management, equipping you with the skills to create more meaningful and maintainable error handling in your applications. Welcome to our deep dive into mastering custom exceptions in Python. In any programming language, exceptions are crucial for managing errors that occur during the execution of a program. Python, with its robust built-in exception hierarchy, offers a wide range of exceptions to handle various error conditions. However, there are times when built-in exceptions aren't specific enough for your needs. This is where custom exceptions come into play. Custom exceptions allow us to create error classes that are specific to our application's context, making the error handling more meaningful and easier to maintain. In this video, we'll guide you through the process of creating and using custom exceptions effectively. By understanding the difference between built-in and custom exceptions, you'll learn when and how to define your own exceptions, inherit from base exception classes, and enhance them with custom messages and attributes. We will cover the best practices for their implementation and demonstrate real-world scenarios where custom exceptions can significantly improve your code's reliability. By the end of this session, you'll be equipped to design and implement your own exceptions, leading to clearer and more maintainable error management in your Python projects. Before diving into custom exceptions, it's essential to understand what built-in exceptions are and how they function in Python. Python comes with a rich set of built-in exceptions that cover a wide array of error conditions, from syntax errors to runtime errors. Common examples include value error, type error, index error, and key error. These exceptions are sufficient for many situations, but there are scenarios where they might not adequately convey the error's specificity or the problem context. The limitations arise when your application needs to communicate an error that doesn't neatly fit into one of the predefined categories. This is where the flexibility of custom exceptions becomes apparent. Custom exceptions allow developers to create unique error types that are more descriptive and aligned with the business logic of an application. They can include additional attributes and methods to provide more context, which can be invaluable for debugging purposes. In this section, we'll explore when and why you might opt to use custom exceptions over built-in ones, setting the stage for creating your own exception classes tailored to your application's needs.
Creating a custom exception in Python is a straightforward process that begins with defining a new class. This class should inherit from Python's built-in exception class, which is the standard base class for all exceptions. Let's walk through the steps. First, define a new class with a descriptive name that reflects the error it represents. For example, if you're creating an exception for invalid user input, you might name it invalid user input error. This naming convention not only makes your code more readable but also helps other developers understand the error's purpose at a glance. Next, implement the _init_ method to initialize the exception class. This method typically accepts a message parameter that provides a detailed description of the error. You can store this message in an instance attribute to ensure it's accessible when the exception is caught. Optionally, you can add additional attributes to store more context about the error, such as an error code or related data. By structuring your custom exceptions in this way, you enhance your application's error handling capabilities, making it easier to maintain and debug. We'll explore code examples to illustrate these concepts in action, demonstrating how to seamlessly integrate custom exceptions into your Python projects. Inheriting from base exception classes is a powerful technique that allows you to leverage existing functionality while creating custom exceptions. The primary base class for exceptions in Python is the exception class, but Python's exception hierarchy includes several other useful base classes, such as value error, type error, and runtime error. By choosing the appropriate base class for your custom exception, you can automatically inherit its behavior and attributes, making your custom exception more robust and compatible with Python's built-in error handling mechanisms. For instance, if your custom exception is related to invalid values, inheriting from value error might be a suitable choice. This approach not only streamlines your code but also ensures that your custom exceptions are consistent with Python's exception handling conventions. Additionally, Python supports multiple inheritance, allowing your custom exceptions to inherit from more than one base class if necessary. This flexibility can be advantageous if your exception needs to combine behaviors from different base classes. However, it's crucial to use multiple inheritance judiciously to avoid complexity and maintain readability. By effectively utilizing inheritance, you can create custom exceptions that are both powerful and intuitive, seamlessly integrating them into your application's error handling framework.
One of the key benefits of custom exceptions is their ability to provide more informative error messages and additional context through custom attributes. When defining a custom exception, it's essential to craft descriptive messages that clearly convey the nature of the error. This practice not only aids in debugging but also enhances the overall user experience by providing meaningful feedback. To achieve this, you can override the _str_ and _repr_ methods in your custom exception class. The _str_ method should return a human-readable string representation of the exception, while the _repr_ method can provide a more technical representation for debugging purposes. In addition to informative messages, custom attributes can be added to store relevant data about the error, such as an error code, timestamp, or related data. These attributes can be incredibly useful for debugging and logging, as they provide additional context that might not be evident from the message alone. By enhancing your custom exceptions with descriptive messages and attributes, you create a more robust error handling system that improves both the maintainability of your code and the clarity of error diagnostics.
Raising custom exceptions in your code is a critical step in implementing effective error handling. The decision to raise a custom exception should be guided by the need to indicate specific error conditions that can't be adequately expressed using built-in exceptions. For instance, if your application has a specific rule for data validation, raising a custom exception like data validation error can clearly communicate the violation. To raise a custom exception, use the raise keyword followed by an instance of your custom exception class. For example, raise invalid user input error. User input is invalid. This statement interrupts the normal flow of the program and transfers control to the nearest enclosing try block that can handle the exception. When integrating custom exceptions into your application's logic, it's crucial to place them strategically where errors are likely to occur. This proactive approach ensures that errors are caught early and handled appropriately, preventing them from propagating unchecked. By mastering the art of raising custom exceptions, you empower your applications with a more precise and meaningful error reporting system, ultimately enhancing code reliability and user experience.
Implementing best practices when using custom exceptions ensures that your error handling is not only effective but also maintainable. Start by adhering to naming conventions that make your exceptions easily identifiable and descriptive. This practice enhances code readability and aids other developers in understanding the purpose of each exception. Keeping your exception classes simple is another important guideline. Avoid adding unnecessary complexity by focusing on the essential attributes and methods that provide meaningful context for the error. This simplicity makes your exceptions easier to understand and maintain. When it comes to inheritance, use it wisely. Only inherit from a base class if it adds value to your custom exception. Overcomplicating the inheritance hierarchy can lead to confusion and bugs. Documentation plays a crucial role in custom exceptions. Clearly document the purpose, usage, and attributes of each exception in your codebase. This practice not only benefits other developers but also serves as a reference for yourself in the future. Finally, thoroughly test your exception handling. Ensure that your custom exceptions are raised and caught in the intended scenarios, and validate that they provide the expected messages and context. By following these best practices, you create a robust and maintainable error handling system that enhances the quality of your Python applications. Handling custom exceptions effectively is crucial for managing errors gracefully in your applications. The primary mechanism for catching and handling exceptions in Python is the try except block. This construct allows you to separate the code that may raise an exception from the code that handles it. A typical try except block begins with a try clause that contains the code that might raise an exception. If an exception occurs, Python searches for an except clause that matches the exception type. To catch a custom exception, specify its class in the except clause. Except invalid user input error as E. This clause captures the exception and assigns it to the variable E, allowing you to access its message and attributes. You can also use multiple except clauses to handle different exception types separately. This approach provides flexibility in tailoring the response to each specific error condition. Additionally, you can include a finally block that executes whether an exception occurred or not. This block is ideal for cleanup operations, such as closing files or releasing resources. By mastering the use of try except blocks, you enhance your ability to manage errors effectively, ensuring that your applications remain robust and user-friendly. Custom exceptions find numerous applications in real-world scenarios, significantly enhancing error management across various domains. In web applications, custom exceptions can handle specific HTTP errors, such as unauthorized access or resource not found, improving the clarity of error messages returned to clients. In data processing pipelines, custom exceptions can signal issues like data format errors or missing data, enabling developers to pinpoint and address problems efficiently. The use of custom exceptions extends to APIs, where they enhance reliability by clearly communicating errors like invalid API keys or rate limit breaches. In financial systems, custom exceptions play a crucial role in error handling for transactions, ensuring that issues like insufficient funds or invalid account numbers are managed appropriately. By offering detailed error messages and context-specific information, custom exceptions contribute to maintaining the integrity of financial operations. Finally, custom exceptions improve user feedback by providing clear and specific error messages, enhancing the user experience and facilitating troubleshooting. Through these real-world applications, custom exceptions prove their value in creating robust and maintainable software systems.
As we conclude our exploration of mastering custom exceptions in Python, let's recap the key points we've covered. Custom exceptions are a powerful tool for enhancing error handling in your applications, providing specific error types that align with your business logic. By understanding how to define, raise, and handle custom exceptions, you've gained valuable skills that improve the clarity and maintainability of your code. We discussed the importance of descriptive messages, the role of inheritance, and the best practices for implementing custom exceptions. These concepts equip you to tackle real-world challenges with confidence, creating more robust and user-friendly applications. We encourage you to practice these techniques in your projects, experimenting with different scenarios to see firsthand the impact of effective error management. Thank you for joining us on this journey to mastering custom exceptions in Python. We hope you found this video informative and inspiring. Keep coding, keep learning, and continue to enhance your Python skills.